So let's give everybody a moment to think about what you look for if it's a plurality winner. For plurality, we think of most popular, right? But it doesn't have to meet a certain threshold. And in plurality and majority, even though they give you information about the second and third and later choices, they don't really matter, right? That's just extra information. So let's just focus in on the first choice. We have a few different candidates, A, B, C, D, and E. Now A secured 4 points. B secured 5. C got 4. D got 3. And E got 2. So from this, I think we'd agree that B did secure the most points, right? B would be our answer there. And that's always going to be the process for plurality. Now I'm going to change the problem slightly. So this is the right answer if this was the case, but allow me to change this here, where instead of that being C, so this is a new problem. So let's focus on what I changed here is I shift the order. I gave A the first place vote and C the second place vote here. Take a moment to think about who would be the plurality winner in this new case. Now, why don't we all send our answers in the chat? And I've highlighted the only change portion. I'll zoom in if it's easier for people to see. So who's now the plurality winner? Thank you, Athos. Sorry about that. Good. So I think we are comfortable with plurality. Let's look forward. I'll give everybody a moment to copy down this next column. Now, it is just majority, so you really only have to worry about copying down the first row, right? Because we only care about first place choice for majority. And then let's all take a bit to think through what we would go to do this process. We would first find the total number, figure out what number is at the cutoff more than 50%, and see if anybody gets that total. Let's work on this on our own for about 2 minutes. And if you have ideas, do send them in the chat. Correct, Caitlin, well done. So the process for majority is we first need to tally up all of the points. So 5 plus 4 plus 4 plus 3 plus 2 in our calculator. I believe that would give us 18 total votes. And then you want to find out what is 50% of that. Now you could either change 50% to a decimal and multiply by 18, or since this only works with the 50%, but it does work out so nice, you could also just always divide the number by 2. Both work, and we get that exactly 50% of 18 is 9 votes. Now a majority is actually more than 50%, so would we agree we need to go 1 up to get the actual majority? So we'd say 10 votes or more for majority. Okay, and then we look, do any of the candidates get more than 10 votes? First place, B gets 5, C gets 4, as does A, D gets 3, E gets 2. None of the candidates get more than 10 votes, right? So in this case, our answer would be that there is no majority winner. Sometimes nobody wins the majority. Now, how are we doing so far? Do we have any questions, anything that we could clarify? Remember, this is review, so we're definitely welcome to anybody's questions. If not, let's continue then. So I'm going to zoom out. Now, in this case, you will want to draw the table because we're about to do the Borda method. So I'm going to zoom in just to the table. And why don't we all take a moment to copy this to our paper? So Borda method. And as you're doing so, if possible, I think it'd be beneficial to leave space so that you can kind of write in the points for each category. So make your table a little spacious. We'll start talking about this problem around 6:13 after people have had time to copy it.
You're muted.
Thank you. Sorry about that, everyone. So if we've had time to, and thanks, Latifah, I appreciate you telling me that as well. We've had time to copy down the table, and we're looking at the Borda method. And with the Borda method, we know that we give certain numbers of points to certain place votes. However, the number of points is not fixed for every board and method election, it does depend on the number of candidates there are. So we'd want to look at the table and figure out just how many different candidates there are. And they even told us here there's only 5 options, A, B, C, D, and E. We could also look at the table and see that there's no others. So it will be described there, but we can also see that in the table. So there's 5 options. We know the first place vote gets 1 less than 5 options, always 1 less than the number. So first place vote gets 4 votes, 4 points per vote. So we'd say maybe 4 points here. And then once you figure out the first place vote, everybody just gets 1 less. And the way that you can check your work to make sure that you're set up in the right way is when you get to the last place vote, you should be left over with 0 points. And that makes sense to us because we know just because somebody puts something in last place does not mean they want that. It just means somebody had to go in the last position. Now we would assign points to each category and then total up the number of points for each candidate. So to begin here, 5 people chose B as their first place vote, but every first place vote gets 4 points. So we would give 20 votes to these groups for B. And you could either write that as like 5 times 4, or in your mind, you could think about it as 20. And we just continue that process. Now, 4 people wanted C as their first place vote. So we would give 4 times 4, 16 votes or points for those votes. We could continue these 4 people chose A. So each of those votes gets 4 points. 3 people chose D. So each of those 3 votes get 4 points. 2 people chose E. So those 2 votes are 4 points each, and they contribute 8 points. Do we kind of see the pattern of where we're getting these different numbers? Okay. Why don't we take a moment then to fill out the remaining 3 rows on our own? I would say in this case, there are a lot of little calculations. Get your calculator, make sure there's no simple errors, and we'll work through that together, and then we'll tabulate it and see our results. And particularly if you've got highlighters or crayons or colored pencil, I think they'd be helpful for the next exam, because what we're going to do at the end is we're going to kind of shade each of the vote tallies for each category, which might help us keep things straight. So we gave the points. Remember the last vote that's not counted out as 0? That one might be fast because it's just 1 times everything. So it's just the number of votes in that category. So we'll just be careful to give the correct number to each individual. So all the B votes the votes for C. And then a lot of C's were at the end. C didn't have too many votes. Okay, and then we'll just calculate each of these. And let's see if we can verify our results. So y'all verify these numbers. A would be 43, B 50, C 31, D 23, E 33. Good. And once we've calculated that and added everybody together carefully, highest points win, no matter what. There's no threshold, just highest points. So I think we would call B the winner of this election. So B's the winner. Great. Now we also learned about the hair method. And as we saw in the notes, we did introduce this additional way of drawing the table, but I did want to make clear that anytime this hair method comes up in the test, I'll draw the same table in two ways. So these are the exact same tables, just based on what each individual prefers work with that table, if that makes sense. So we're going to go through the hair method. And remember, the hair method first says, does anybody win a majority? Because we know one of the drawbacks to the Borda method is that somebody could win the majority but still lose a Borda election if things were skewed just the right way. So the hair method starts off with its first declaration of, if anybody wins the majority, they're the winners. So let's first calculate, what is the majority cutoff, and does anybody reach that in the first choice preferences? So why don't we all take a moment to calculate the majority number, and send your idea for what the majority cutoff is. What or higher is the majority in the chat? Good, 10 plus, exactly right. This is the same example, just we're doing the different methods each time. So we would add them all together and we'd say there's 18 votes in all. Divide that by 2. Gives us 9 is 50%, but we want more than that, so 10 or more for majority. And if we look through the first place votes, we will see that nobody secured 10 votes or more. The most anybody secured was 5. So the hair method says whoever had the least number of votes, you've got to exclude them of the first place. So look at here and let's type in the letter in the chat. Who do you think got the least first place votes? What letter should we eliminate? I think we'd agree with E, correct? E got only 2 votes. Now, we don't toss out these votes completely. We just say this candidate is definitely not going to win. But if you can't have E as your first choice, who do you want in its place? And do we see A comes up to be counted as those 2 points? So that's the idea. Let's write down, we just went through a round 1 where we said A, B, C, D, and E. E got the lowest number of points, so it was kicked out, but let's record the other points. First place only counts for hair method, so B got 5. A and C both got 4. D got 3. So then you go to round 2, where now this extra vote has been shifted to A. So only A's total changes. It had the original 4 plus now the 2. B, C, and D remain unchanged. So A now has 6 votes, so it's taken the lead. But still nobody hits the 10 or more threshold, so we eliminate the next lowest or lowest performing candidate. Would we agree that would be D now? So D gets eliminated. So we look at the chart, who picked D as their first place? These 3 individuals did, but they said if I can't have D, I'd rather have A of the other options. So now in round 3, do we see A picks up 3 more votes? Okay. So I'll write round 3 over here. There's only A, B, and C. Now A gets these 4 votes, these 3 votes, and these 2 votes. So they're at 9 votes now. B is still at the original 5, C is still at the original 4. But even though A is winning, can we call it the winner yet? No, because remember, the hair is looking for a majority. So even at this point, just having 9 is 50%. We need more than 50%. So you then eliminate the next lowest performing candidate, which in our case would be C. So you look at the people who voted for C and you say, who did you want next? Do we agree they also wanted A, and that's going to push us over the top? So now A is decidedly the winner. And sometimes the hair method does take quite a few rounds, but you will, if you keep going through the progress, eventually get a winner. Somebody will get more than 50%. So A now has, we've added in 4 more to A. 4 plus 4 plus 3 plus 2, and that should put us at 13, whereas B only had 5. That's over the majority, so A is the winner. So we would just select A. Now, any questions about the hair method? Do we see what would separate it from the border method? And do remember that y'all do have a piece of paper, right? So you can use that as your note sheet, write good notes for that to kind of help step yourself through the election. Now this is a new table. If you want to copy it down, we will, on this one table, go through the majority and the border election method. So what we're doing first is we're going to find the total number of participants. We start by adding up all of the candidates here, and we would get 36 voters. Okay. We know if we're looking for the majority, we need to know what is 50% of that. So we would divide that by 2 and we get 18. We know that's exactly 50%. So the next integer gives us the or more than 50%. So we need 19 votes to declare a majority or more than 19. And we're asked if anybody wins the majority. So just looking at our first place votes, would we agree that candidate D does get 19 votes exactly? So they do secure the majority win of first place votes. And then they do ask us to evaluate a Board election. Remember, a Vorda election has to do with points that are dependent on how many candidates you have. Would y'all agree, looking through the table, that we only have options A, B, C, or D? Okay, so there are 4 options available. So think about how many points would go to the first candidate in a Vorda election. Isn't it always 1 less than the number available? So if we have 4 available choices, the first place gets 3 points. Always 1 less than the number available. And then to figure out the remaining points, you just give 1 less each time you go down. So 2 points for second place, 1 point for third choice. And you know you'll done this right if the last place gets 0 points, which makes sense because there's 0 points there, right? It's not really a choice. It's the place you had to put things. We then give that number of points per vote in that category. So we have 3 points given to these 4 voters, 3 points given to these 9 voters, 3 points given to these 4, 3 points given to these 19. Give everybody a moment to fill in their table. There was a very good suggestion sent in the chat. It said, would it not be easier to start at the bottom with 0 and go up? I think that's a great suggestion. Never thought of that before, because then you don't have to think about it, right? If you always start here with 0 points, go up would be 1, 2, 3. That's really good. So I think that's a better suggestion. Start at 0 and go up. Then you don't even have to worry about how many points each time. After we give out the points, we do collect them per category, add them all together, and we know highest points will win. So based on this, let's see who would win this election. Do we agree C? Because it did get the highest number of points, which was probably not what we were expecting because D did win the majority. It's just that C had more lower ranked choice votes available. Now, one of the things we learned in class is the idea that sometimes the Borda method in this violates the majority criterion, which means the majority criterion is if a majority of people want something as their first choice, that should be the outcome of the election. That's just one of the criterions in voting theory. And in this case, I think the Borda method fails, right? Because D did win the majority, but it lost the election. So this is an example of it failing. So does using the Borda method violate the majority criterion? I think we would say yes, it does. Because D wins majority, but loses Borda election. And that covers our different voting methods. Let's then go to the apportionment methods. And we focused on two methods, the Jefferson method and the Huntington Hill. Now, as y'all take y'all's quiz from this section too, you'll kind of see how they could look rendered on a computer, right? So, but this is an idea where we can fill in all the chart. Let's all take a moment to read through this. Now, as we're dealing with this apportionment method, we know we have two techniques for two different methods. So let's focus in on the fact we're asked for the Jefferson method. So we'd look at our notes and we'd see, what do we do with the Jefferson method? Well, first we have to find the MQ. And we've been told that our modified divisor is 40. So the way you find the modified quota, MQ, is you take the number of members and you divide it by the divisor. So here I would write 360 divided by 40, and we have been asked to, wherever necessary, round to 2 decimal places. So if we do need to round, let's do so to 2 decimal places. Do we agree with these values so far? Now the last step in these is we do have to figure out how we're going to round this MQ. And for the Jefferson method, the rule is pretty quick. We just always round down no matter what. Even if you're very close to the next integer, it's always round down. Now, what do you do if you're already at the integer itself? You just stay at the integer. So you don't go down to the next one. So 9 stays to 9. But 7.88, even though normal rounding rules would take that up to 8, Jefferson method just says round everything down. So it's like you would just cover up the decimal place and just copy that over. That's kind of what we're going to copy there. And based on the number of members, that's how they're going to decide where the 21 tutors are going to go. 9 are going to go for math, 7 for English, 3 for chemistry, 2 for biology. Any questions with that one? Give everybody a moment to read through this one then. Why doesn't everybody get started finding the MQ? I think we get these values when rounded to 2 decimal places. Do y'all agree, or does anything need to be corrected? Okay. Now, with Huntington Hill, we always have this extra column, and it helps us remember what we're doing. We need to construct this other thing to help us know whether we round up or down. The way you find it is you always just cover up the decimal part with your hand. That's your A for this column, or this row, 4. How do you find B? B is always 1 more than that, so B is 5 in this case. So then we would look at what's the square root of 4 times 5, or equivalently the square root of 20. And let's round that to 2 decimal places as before. So you always cover up the value. What's the integer part? That's your A. Plus 1 is the B. Multiply them together. So 4 times 5, then take the square root. And I believe to 2 decimal places, we get 4.47. Now, why don't we all take a moment to find the remaining square root of ABs on our own? And we notice that since this has the same integer start of 4, this AB will be the square root of 20 again, which is 4.47. This one, integer start for mathematics is 3. So A is 3, B is 4. We'll take 3 times 4, which will give us 12. Take the square root of 12, and we should get about 3.46 when rounded. So this is the one thing to remember with the Huntington-Hill method. Any questions here? If not, then let's talk about the final rounding decision. What you do is you compare each row at a time. You look at the actual value of interest, and you compare it to the square root of AB value. If the value of interest is higher than the AB value, you go up. But if the actual value is lower than the square root of AB value, you go down. So right now we're comparing 4.53 and 4.47. And would we agree 4.53 is above 4.47? That means we round up. So we're going to round up to 5. Take a moment to think about the remaining two and round them. If your actual value is above the square root of AB, go up. If your actual value is less than, go down.
Question, Ms. Wood.
Yeah.
Like when you're trying to find the square root of 20 and you come up with 4.47, how are you getting that?
Do you have this kind of button on your calculator that you can see on my screen?
I don't know.
Okay. Do you have this button that looks kind of like an upside down V? Okay. So Tiffany, what you'll want to do is type with me parenthesis,
Okay.
20, close parenthesis, exponent button. And now this is key. Since there's many things in the exponent, you do have to write parentheses 1 divided by 2, close parentheses. And what you might do as a reminder to yourself is on your note sheet, couldn't you write square root of 20 and then kind of write out the symbols and you could follow that along? Because this square root of raising to the 1/2 is the same as the square root symbol. Does that make sense?
Yeah, I think so.
Yeah, just look for these symbols in your calculator and type them.
Okay, thank you.
Now, as we compare, 4.84 is larger than the square root of AB, so we round up. That would give this also to be a 5. However, 3.44 is slightly smaller than 3.46, right? Just barely. So in that case, we would round down and we'd just go down to 3.